For years, engineers have dreamed of building humanoid robots that could navigate the real world like we do, walking, climbing, carrying objects, and responding to the chaos of daily life. But for most robots, something as ordinary as walking down a staircase remains a massive challenge. They hesitate, wobble, sometimes freeze entirely. But now, Tesla's Optimus Gen 3 has shattered expectations. In a recent demo, Optimus descended 5 stairs, not in slow, jittery steps, but in a smooth, confident 7 seconds. No cables. No human pilot. Just a robot moving with control and poise. So what changed? What kind of engineering magic made this breakthrough possible? Let's unpack it. To understand how far Optimus has come, it helps to remember where it started. Earlier prototypes could only walk on flat, open surfaces. Stairs, ramps, or any terrain that wasn't completely level posed a serious risk of imbalance or failure. In fact, tests in early 2025 showed that it took the bot nearly 20 seconds to make it down a basic 6-step staircase. Each movement had to be cautious, calculated, and slow. But Tesla wasn't satisfied with caution. With the Gen 3 version, they decided to solve the problem of mobility head-on. The foundation of this improvement lies in how the robot senses the world. Optimus Gen 3 is equipped with an advanced sensor system that includes 8 high-resolution cameras, multiple LiDAR units, and depth sensors. Together, these allow the robot to detect the dimensions of every step, the height, depth, angle, and any unexpected objects like a stray toy or a loose shoe. But perception alone isn't enough. The real magic happens in how Optimus interprets this data. Every time it approaches a staircase, it performs over 100 real-time calculations just to figure out where and how to place its foot. And it does all of this in less than 1/5 of a second per step. Helping it along the way is a suite of force sensors embedded in the feet, knees, and ankles. These sensors measure ground pressure thousands of times per second. That means Optimus knows instantly if its foot is slipping, or if it's putting too much weight on one side. It can adjust the force in its joints on the fly, correcting balance and avoiding a fall. It's a level of bodily awareness that even some animals don't have. Under the hood, Tesla has equipped the robot with the same AI backbone used in its self-driving cars. That software, originally built to navigate highways, is now running Optimus Motion System. And just like Tesla's vehicles, the bot learns rapidly from trial and error. If it miscalculates a step during testing, the internal software adjusts the movement logic within hours. It doesn't just react. It evolves. Tesla also gave the Gen 3 version more flexible joints. The knees, for instance, can bend up to 45 degrees in both directions. Combined with the robot's ability to simulate movement virtually before acting it out, it gives Optimus a kind of predictive awareness. It doesn't just feel the ground, it anticipates it. And then there's Grok AI4. This is Tesla's latest and fastest language-based neural system, and it's doing more than just processing speech. It allows Optimus to understand contextual commands like, bring the basket downstairs, then figure out how to do that even if the path is cluttered or the lighting is dim. It even considers unpredictable elements like a dog suddenly crossing the stairway. Grok gives the robot a new level of adaptability, allowing it to function in real-world spaces designed for people. Now, what does all this mean in practice? It means Tesla Bot Gen 3 is no longer limited to just moving across flat floors. It's starting to do meaningful work, carrying items, climbing stairs, and navigating real homes with real people. And that opens the door to more than just household tasks. With continued improvements, Optimus could soon be used in places like hospitals, hotels, or even warehouses with complex layouts. Of course, it's not perfect yet. Its stair descent is still on the slow side, averaging 0.2 meters per second. That may sound cautious, but for now, it's a necessary trade-off for safety. Tesla's engineers are continuing to refine the force prediction and balance algorithms to shorten decision times and make motion smoother. But even in its current form, Optimus Gen 3 is closing the gap between itself and robots from companies like Boston Dynamics or Agility Robotics. The humanoid race is officially heating up. Now, let's talk about balance, because this is where the Tesla bot's design really starts to impress. When most people walk downstairs, they don't consciously think about balancing. We just do it. Our bodies shift weight, bend joints, and keep our center of gravity steady. Optimus is learning to do the same thing. Tesla engineers studied how human balance works and built those principles into Gen 3. Instead of keeping a stiff frame, the robot allows its pelvis to sway slightly as it moves, just like we do. This adds fluidity to its motion, makes walking more energy efficient, and reduces strain on the joints. It's a simple concept with huge impact. As the robot moves over a ramp, it tilts its torso forward just enough to maintain balance without toppling. It adjusts ankle torque and redistributes weight across both legs in real time. This is made possible by a series of internal simulations that run over 1,000 times per second. Each one asks, what's the safest next step? Then it picks the best option and executes it almost instantly. And in those moments when something goes wrong, say, a foot slips on a smooth surface, Optimus can recover. It shifts weight to the opposite leg, tilts its hips, and even extends its arms if necessary, all in under 100 milliseconds. That's not reaction speed. That's survival speed. All of this happens untethered. Unlike many robots that rely on external support cables or follow pre-recorded paths, Optimus Gen 3 is moving independently. It can walk diagonally across slopes, turn mid-step, and still maintain perfect posture. Energy efficiency is another key area Tesla is optimizing. When walking downhill, for example, Optimus doesn't resist gravity, it works with it. The robot leans slightly forward and uses regenerative braking in its joints to control the descent. As a bonus, that braking motion sends a small amount of energy back into the battery system. Smart, sustainable, and futuristic. Looking ahead, future versions of Grok AI are expected to give Optimus even more context awareness. That means better understanding of floor textures, dynamic environments, and user habits, all learned from vision and sensor data. It's the difference between a robot that walks and a robot that lives alongside us. So where does Optimus fit in today? Right now, it thrives indoors. Homes, offices, stores, warehouses, places with consistent lighting and flat or gently sloped floors. It's already capable of carrying light objects, navigating furniture layouts, and avoiding humans and pets. It fits through doorways, walks in hallways, and knows how to avoid bumping into chairs or tables. Tesla has tested the robot using real residential layouts to make sure it performs in believable scenarios. And since most homes are already designed with human proportions in mind, standard stair heights, shelf depths, and furniture spacing, Optimus slides right in. Compared to outdoor use, where unpredictable terrain, weather, or obstacles could trip up the bot, indoor environments provide the perfect training ground. That's where Optimus will likely see its first wave of real-world applications. Imagine it helping seniors move around safely or assisting in childcare by delivering supplies. Maybe it keeps an eye on the home while connected to a smart system, or simply helps clean and organize. The possibilities are growing with every update. So while Optimus Gen 3 isn't ready to hike a mountain just yet, it's proving to be one of the most capable humanoid robots on flat ground, and it's only getting better. Thanks for watching. If you enjoyed this deep look into Tesla's incredible progress, consider subscribing.